Okay, so this is Jacob's Algebra, Chapter 13, Lesson 7, Part 2. In the Part 1 video, we had already worked through problem numbers 4 and 5a. Now we're going to work on number 5, Part B. Now, for all of number 5, we're going to be working with this root equation here, x squared minus 6x equals 12. For Part A, we were asked to solve the equation by completing the square. And to complete the square, we had to take the x squared minus 6x, figure out what that would be in a binomial square, what we would have to add to both sides, and then take the square root of both sides and solve for x. So when we solved it by completing the square, we got 3 plus or minus the square root of 21. So now for part B, we need to solve it by using the quadratic formula. Now remember, when we're going to use the quadratic formula, we always have to have our equation in standard form. So we're starting off with x squared minus 6x equals 12. That is not standard form. To put it in standard form, we'll need to subtract 12 from both sides. When we do that, we'll get x squared minus 6x minus 12 equals 0. Now, to do the quadratic formula, we have to find what a, b, and c are. A is the coefficient in front of the x squared. Since there isn't a number there, it's understood to be 1. So I'm just going to write a equals 1. B is our coefficient in front of the x. That is negative 6. Remember, you have to grab the sign that's there also. So our b is negative 6. And then c is going to be our constant. And that is negative 12 here. You have to grab that negative sign also. Okay, so now we can plug all these values into our quadratic formula. The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. Okay, so now let's plug our values in. Negative b, that means the negative of negative 6. Well, the negative of negative 6, actually I'm going to write that down below. The negative of negative 6 is a positive 6. Then we write our plus or minus, and then our square root symbol, b squared. Well, our b is negative 6. When we square negative 6, we get a positive 36. Then we have a minus 4 times a times c. Well, so we'll copy our 4. Our a is 1, and then our c is negative 12. And all of that is over 2a. Since our a is 1, the double of that is just a 2. Okay, so now let's look at what we have over here inside of this square root. I'm going to write that up here at the top since we're kind of running out of room. We have 36 minus 4 times 1 times negative 12. Okay, so that is the square root of 36. Negative 4 times 1 is negative 4. Times negative 12 is going to be a positive 48. So what is 36 plus 48? Well, that's 84. So this is actually the square root of 84. Now, this is not simplified because 84 has a square factor. We can write 84 as the square root of 84 as the square root of 4 times 21. When we take the 4 out of the square root, we get 2 times the square root of 21. So I'm going to rewrite this equation now as 6 plus or minus 2 times the square root of 21 all over 2. Now we're not done yet because you might notice that everything in the numerator has an even coefficient. So I'm going to pull a 2 out of our numerator, and we will have 2 times 3 plus or minus the square root of 21 all over 2. Our 2's cancel, and so we end up with x is equal to 3 plus or minus the square root of 21. You'll notice that is the same answer that we ended up with when we used completing the square. Okay, so now Part C asks which method for solving this equation is easier. Well, it kind of depends. If you have an easy time with the completing the square method, then completing the square might be the easier method for you. But a lot of people have a very hard time with completing the square, and so they'll find the quadratic formula easier. Okay, so that was problem number 5, which is just like problem number 12 that was assigned for homework. So now let's look at problem number 6. Problem number 6 uses the equation x squared plus 3x plus 1 equals 0. So all of number 6 is about this equation. Part A says to solve the equation by completing the square. Okay, so to complete the square, we need to have our x terms on one side and our constant on the other. We're going to do that by subtracting 1 from each side, and we'll end up with x squared plus 3x is equal to negative 1, because we subtracted 1 from both sides. Now we need to write this as a binomial. So I'm going to write my parentheses and draw my square. Take the square root of the first term. The square root of x squared is x. I'm going to take my second term, 3x, and divide it by 2, so that's 3 halves x. Then divide it by our x, so that's going to be 3 halves. So now I need to square this and write this up above. X squared is just x squared. 2 times x times 3 halves is 3x. That matches, so we're good. Now I need to square my last term. The square of 3 halves is 9/4. And then I copy what I have on the right side. And since I added 9/4 on the left, I have to add 9/4 on the right. Now, negative 1 is the same thing as negative 4/4. So when I add 9/4 to that, I end up with 5/4. So x plus 3 halves, when we square it, is going to be 5/4. Now we need to take the square root of both sides. So when we take the square root of the left side, what we end up with is x plus 3 halves is equal to plus or minus the square root of 5/4. But we can actually take the square root of 4 because 4 is a square. What we actually get is plus or minus the square root of 5, and that is over 2. Make sure you draw this fraction bar where you can tell that the 2 is not inside of it. So now I need to solve for x. I'll do that by subtracting 3 halves from each side. So our x will equal negative 3 halves plus or minus the square root of 5 over 2. Or I can rewrite this as negative 3 plus or minus the square root of 5, and all of that is over 2. This is the typical way to write it as a single fraction. Negative 3 plus or minus the square root of 5 over 2. And part C asks which method for solving the equation is easier using the quadratic form. Oh, I'm sorry, we haven't gotten to that part yet. We need to do part B now. So let's do new page. Number 6, part B, asks us to solve it by using the quadratic formula. So the equation we started with was x squared plus 3x plus 1 equals 0. This is already in standard form, so we can just copy our values for a, b, and c. A equals 1, b equals 3, c equals 1. Because there's no coefficient written in front of the x squared, it's understood to be 1. The coefficient in front of x is 3, and our constant here at the end is 1. So now we plug all of this into the quadratic formula, which is x equals negative b plus or minus the square root of, I'm sorry, I don't know why I put a 4 there, the square root of b squared minus 4ac, and all of that is over 2a. So now we're going to plug our values in. Negative b means the negative of 3, which is negative 3, plus or minus the square root of b squared. The square of 3 is 9, minus 4 times a, which is 1, times c, which is also 1. And all of that is over 2a. Since our a is 1, 2a is going to be 2. So our x is equal to negative 3 plus or minus the square root. 9 minus 4 times 1 times 1 is 4. So 9 minus 4 is 5. All of that is over 2. And you can see that this is the same answer that we got on the previous page. Negative 3 plus or minus the square root of 5 over 2. But we got it much quicker. This was a much easier method for this problem. Okay, so Now let's look at number 7. Oh, and number 6 was just like number 13 that was assigned for homework. So number 7 says solve the following quadratic equations. Express the answer either as an integer or in decimal form correct to the nearest tenth. So let's just work a couple of parts here. Let's look at part D. Part D says x squared minus 7x plus 3 is equal to 0. So to solve it using the quadratic formula, we need to find our a, b, and c. This is already in standard form, so our a is equal to 1. Our b is equal to -7 because that's our coefficient for x. And our c is equal to 3 because that is our constant. So x is equal to -b. The negative of -7 is +7. Plus or minus the square root of b squared. The square of -7 is 49. Minus 4 times our a times our c. All over 2a, since our a is 1, 2a is 2. Now we're going to rewrite this as 7 plus or minus the square root. We have 4 times 1 times 3 is 12, and 49 minus 12 is 57. No, 49 minus 12 is 37, not 57. All over 2. And that's our answer, except that it said to give the answer as an integer or in decimal form correct to the nearest tenth. So since it says to put this in decimal form, that means we need to actually punch the square root of 37 into our calculator. So what we'll end up with is x is equal to 7 plus or minus 6.1 over 2, because the square root of 37 is about 6.1. So 7 plus 6.1 is 13.1 over 2. And then our other value is 7 minus 6.1, which is 0.9 over 0.2. So our actual values for x here are going to be, are going to be 6.6 and 0.5, because it says to give the answers to the nearest tenth. Okay, let's look now at part E, number 7E. That is x squared minus 8x plus 3 equals 0. So again, this is already in standard form. We can just write down our values for a, b, and c. The coefficient for x squared is 1, so a equals 1. The coefficient for x is -8, so our b is -8. And our constant is 3, so our c is 3. We're going to plug that into the quadratic formula. X equals -b, so the negative of -8 is +8, plus or minus the square root of b squared. The square of -8 is a +64, minus 4 times our a times our c, all over 2a, which is going to be 2. And so what we're going to end up with here on the top is 8 plus or minus the square root. 4 times 1 times 3 is 12. 64 minus 12 is 52. And so we get 8 plus or minus the square root of 52 all over 2. And again, on this problem, it says to give the answer in decimal form correct to the nearest tenth. So when you punch square root of 52 into your calculator, what you're going to find is x equals 8 plus or minus 7.2 over 2, because the square root of 52 is about 7.2. So 8 plus 7.2 is 15.2 over 2. And then our other value is 8 minus 7.2, which is 0.8 over 2. So now we need to calculate these values. 15.2 divided by 2 is going to give us 7.6. 0.8 divided by 2 is going to give us 0.4. So 7.6 and 0.4 are the two values for number 7, part E. So in our part 3 video, we'll work through numbers 8, 9, and 10. This was number 7.